Hey guys, I've gotten a lot of questions about how to find the linear regression line and the correlation coefficient in Excel, so I wanted to make this video to walk you guys through it really quick. So let's go ahead and begin. I've gone ahead and put the formulas that we have been given in the lecture videos on here, so if you have questions about the motivation or where these come from, those are in the lecture videos, and we have a sample data that has been collected. So the first thing we're going to do is we're going to take our data and put that into Excel. So we want to have two columns, one for our X and Y, and we're going to just enter in our data manually. So we have 8700 for 17111. 7 is 20562, and 9 is 36400. Okay, so now that we have entered all the data, we want to sum the data, and that's because we can see here that the sum of the X values and the sum of the Y values in our formula. So what I like to do is just go ahead and do a thick line so that you can tell the difference, and we just use the Excel sum function and sum our X and our Y values. Alright, so the next thing we see that we need here is the product of our X and Y values. So we'll just make another column, Xi, Yi, and we'll just program this to be the product of our X and Y values, and we'll drag it down. And then again, since we want the sum of this, we'll program that in. Okay, now the only other thing that we need here is going to be this part right here, and that's because we want the sum of each X value squared. So we have Xi here, and we'll just do it times itself, or you could do square, same thing, and drag it down and sum those as well. Okay, and then our final value, this sum of the Xi value squared, that's really just the sum of the Xi values. We already have that here. We're just going to square that so we can program that in pretty easily. So we have A equals, and we want it to be a fraction. I like to put the parentheses in first to make sure that we don't have any calculation errors. And then we have we have 5 values, so that's going to be 5 times the sum of the product of our X and Y's, which is this right here, minus the sum of our X values, which is this here, times the sum of our Y values, which is this cell here. And then we have again 5 times, then we have the sum of our squared values, and you want to subtract that from the sum of our X values, which is this cell here again, and we want to square that, and that'll give us our A. And then for our B, we have, again, we're going to divide by 5 here, and I'm going to go ahead and put parentheses here, and we're going to have the sum of our Y values minus our A, which is here, times the sum of our X values. And so now we have A and B, and then I like to go ahead and insert an equation in so that we can write it out nice and clearly. And we have y equals 3493.412x plus our b 1524.907. And now we have our linear regression line for the given data set. And the next thing we want to do is calculate the correlation coefficient. And in order to do that, we're going to need some additional information. So the first one we want is y bar. And what we can do is we can just take our sum and divide it by the number of entries. Or you can also use the average function in Excel. And there's lots of different ways to do it, but as long as you get the correct y bar, it's kind of up to you. And then we want to make a ST and SR column. And as we can see, ST is going to be a sum, and so we're going to go ahead and do it for each y value, and we'll sum it up much like we did for the linear regression line. So we'll just program in here equals yi, so we'll take the first y value, and we'll subtract that from our y bar value, and we want to take this and square it. Now the best way to do this is we want our y bar is not going to move. It's a fixed value. It doesn't change. And so if you press F4, as you can see, it puts the dollar signs in there. That'll make it a fixed cell. You can also just type in the dollar signs manually, and that'll also work. So we'll take this and we'll drag it down. And if we look at our last value, we can see that y bar has remained the same, and it's using the final y value, which is what we want. And so then down here we just want this to be the sum of that, because that's what our ST is. It represents the sum of all these different values. Well, for SR, we're going to do, again, the first y value. We're going to subtract from A. So again, we want our A to be fixed. That's not going to change, so I'm going to do F4. A times, we want our first x value, plus b, and again that's fixed, so we'll do F4. And we want to square that entire quantity, and then we just drag that down and we sum that. Okay, so now we have all these values that we need. So over here we can finally do R, and as we can see, it's a square root, so we will just use Excel's square root function, and it's going to be division. So we're going to have ST minus SR divided by ST, and now we have our R as well. So as you can see, using the functions in Excel, we can easily calculate the correlation coefficient and our linear regression line fairly easily. And right now, in the next couple weeks, we'll be looking at some different methods to doing this, and in addition, some different techniques in Excel that we can use. But I'm gonna go ahead, if you are interested in seeing, I'm gonna go ahead and show you what you can do kind of quickly to check if this information is correct. So if we take our X and Y data and we just highlight it and go insert scatter plot, it'll give us this nice little chart here. And if you click on one of the points of data on the chart and right click, you can go down to add trend line. And we are doing a linear trend, and so as you can see, that's clicked. And if we just click display equation on chart and display R squared value on chart, it puts this right here on our chart, and we can check that this y equals 3493.4x plus 1524.9, so we can see that is correct. And then they do r squared instead of r, so you have to go and take your r value and square it to check. But as you can see, we have 0.9264, 0.9264, so we can see that we have in fact calculated it correctly. Alright, I hope this helps you out. If you have any questions, please let me know.